Welcome everyone to today's astronomy talk. I'm Dr. Dana Gersovich, the Outreach Coordinator for Columbia University's Astronomy Department. Today we'll be hearing from Dr. Emily Levesque, a professor of astronomy at University of Washington. She's an expert in the structure, evolution.
Welcome everyone to today's astronomy talk. Oops. I'm Dr. Dana Gersovich, the Outreach Coordinator.
Sorry about that. So she's an expert in the structure, evolution, and death of massive stars, and her work has been recognized with the prestigious Newton Lacey Pierce and Annie Jump Cannon Awards from the American Astronomical Society. She is also the author of this wonderful popular book, which I'm in the middle of and enjoying a lot. It's called The Last Stargazers, The Enduring Story of Astronomy's Vanishing Explorers. So we're very lucky to have her here to share some stories from her book and her experiences with astronomical observation. And before I pass it over to her, I want to let everyone know that we'll be monitoring the YouTube chat for questions. So if you have any questions during her talk, feel free to type them in the chat and we'll have a Q&A after Dr. Levesque is done speaking. So welcome, Emily. I'll hand it to you.
So thanks so much for inviting me. I will go ahead and share my screen so I can share some of the pictures that I like to use when I accompany talking about my book and talking about my experiences as an observer. So can you see the slides well? I'm seeing a thumbs up, so that means you can see them. Excellent. So as mentioned, I'm an astronomy professor at the University of Washington, and my research is focused on how really big stars evolve and die and make things like a supernova and a black hole. I've written a couple academic books about my research, but The Last Stargazers, which I'm talking about today, was my first popular science book. And it was my first introduction into the world of popular publishing. And I got the wonderful opportunity to go to a couple publishing and library conferences earlier this year. And I've since had the chance to speak to lots of libraries and sort of learn a bit about the literary world. And something that came up as I talked to other authors and talked to real book enthusiasts was a lot of interest in the first lines of books. People would ask, oh, what's the first line of your book? Or what's your favorite first line or opening line of a really great book? And people are remembering these wonderful phrases that sort of transport you into a fantasy world or start off a mystery or just grab your attention right away. And it got me thinking, okay, well, what's the first line of my book? My book is about what it's like to be a professional astronomer, all the incredible adventures that we have, and really what it's like to have a job answering the mysteries of the universe. Okay, how does my book actually start? And the opening line of my book is, have you tried turning it off and on again? So I realized this and kind of went, oh no, but there's a reason for this. This sentence, have you tried turning it off and on again, marked one of the more alarming experiences that I've ever had at a telescope and is how the opening story of my book begins. So I had someone ask me this, a phrase that we're probably used to hearing when we're on the phone with Comcast complaining about our Wi-Fi, while I was sitting here. I was sitting inside the Subaru telescope atop Mauna Kea Observatory in Hawaii. So this telescope is, just like it looks, the size of a building. The telescope has a main mirror that is about this big. So this is me standing beneath another telescope, with an almost identically sized mirror. That mirror is more than 8 meters from end to end. You can see me standing under it for scale. I'm about 5'2". So I was sitting in this just building-sized, exquisite scientific instrument. And in the middle of my night of observations, one of the computers in the room I was sitting in made this awful blunk sound. And I looked over at it, and then I looked at the only other person with me at that telescope, who was the telescope operator. And the operator is specifically trained to understand and operate a huge involved instrument like this. She looked over at that computer and she looked back at me, and I'll never forget what she said. She said, "It's okay, I think the mirror is still on the telescope." Now look at the size of this mirror. I didn't realize that it was an option for mirrors to not be on telescopes. I thought they were, built to stay. And she eventually explained to me what we thought had happened. This is an illustration of what a typical modern telescope looks like. And in this picture, the giant mirror that I just showed would be near the bottom of the picture, kind of lying on its back and pointing straight up. That main mirror is how we collect the starlight that we observe, and the mirror will focus it to a point high above that base mirror of the telescope. It might focus it to a camera, it might focus it to another mirror that bounces it to a different camera, and it might generally send the light somewhere else in the telescope's optical system. In this case, Subaru was designed to send that light up to a secondary mirror suspended high above the telescope. And that's what you see in that long tube at the top of this picture. Apparently, what that alarm had meant was that the mechanical structures supporting that secondary mirror had failed. They were used to automatically supporting the mirror as we tipped the telescope back and forth, but the blunk meant something had gone wrong and the mirror might not be supported anymore. And as she explained, that meant that if we tipped the telescope too much, that mirror hanging high above the telescope was at risk of sliding off. If we were lucky, it would go crashing to the concrete floor and probably break into several pieces and leave a dent in the concrete floor. If we were unlucky, it would hit that enormous main mirror on the way down. So we called the crew in charge of operating the telescope and said, what do we do? And the answer came back saying, oh, that's probably a false alarm. The computer's probably just reporting a problem where none exists, and it's probably okay. There was a lot of probably. If you just turn the telescope off and back on again. And I remember sitting on the phone with them going, I'm totally fine with this as a fix for a modem. I'm not sure I'm going to do this with a building-sized scientific instrument. And I was stuck trying to decide what to do. I was at Subaru to do research for my PhD thesis. I had applied to a committee describing the research that I wanted to do and why that research was worth a precious night of time on a big telescope like this. If I called the night off and I said, oh, the telescope might break, I should cancel, then I would lose that night of access. I'd have to wait months or even an entire year to get the data that I needed to finish my PhD. On the other hand, I'd heard stories about telescopes that broke, and I was terrified that I was about to live through one of them. There's a famous story about a giant radio telescope in Green Bank, West Virginia. You can see the picture of how enormous this telescope was. It had a radio dish that was 300 feet from end to end. You can see how it dwarfs the building that's under it. And this telescope quite famously collapsed one evening. It went from this to this. Now, in that telescope's case, there was a minor engineering mistake in one of the support struts, and the issue wound up being nobody's fault. But in my mind, sitting at telescope, I was going, oh my God, I bet they tried to turn it on and off again and it didn't work. And I remember sitting there just going, what do I do? Do I risk breaking this telescope but get the data that I desperately need for my research? Or do I pack it in and risk delaying or perhaps even permanently ending part of the research that I'm trying to do? And that's how my book starts. So my book kind of takes a behind the scenes look at how we observe things like this. Everybody loves sort of the beauty and the majesty of space, and people love admiring photos like this of these gorgeous galaxies or supernova or nebulae that we just see glowing away in space. But we don't think that much about the story behind these photos, and specifically about the people and professionals that actually capture them. If you picture an astronomer, you're likely to picture something like this. People tend to picture a man. He's, for some reason, always got a beard. He's wearing a lab coat for some reason. We definitely don't wear lab coats in our day-to-day work. And he's usually standing next to a very cute little telescope on a tripod in a backyard, getting ready to look through it with his eye. And this is the mental image that we have of professional astronomy. It's not really surprising because on a planet of 7.5 billion people, only about 50,000 of us are professional astronomers. So odds are most people haven't had the chance to hear from a professional astronomer or hear us tell our stories and kind of the background of what our jobs are like. I definitely was one of those people that had no idea what an astronomer did growing up, but that did not stop me from wanting to be one. This is a picture of me at age 6, and I'm proudly sporting my new Hubble Space Telescope t-shirt. Hubble had launched earlier that year. My brother describes the look on my face in this photo as the "what do you mean 6-year-olds can't use Hubble" face. But I was obsessed with space, even from a really young age. I thought space and planets and stars and black holes were just the coolest thing ever. And I was convinced I wanted to study them for my job, even though I had no idea what a scientist's job was actually like. I might see the occasional scientist in a movie, but nobody in my family was a professional scientist. Nobody in the town I grew up in was a scientist. It just seemed like a neat job, but I kind of went through school interested in science, but not really sure what my job would be like. I didn't get a good glimpse of that until halfway through college. After my sophomore year of college, I got to go here to Kitt Peak National Observatory in Arizona for my very first night working at a professional observatory. I was working with my research advisor at the time, Dr. Philip Massey, and we were observing at one of the many telescopes atop Kitt Peak. So Phil brought me to the mountain, and we went to dinner on our first night with all of the other astronomers using the other telescopes on the mountain. Phil introduced me saying, this is Emily, she's a brand new astronomer, this is her first night at the telescope, and everybody at dinner just went, oh, that's great, that's so cool, you're gonna love it. Here, you should remember to drink some coffee at midnight so you don't just crash at 3 a.m. You should remember to do this and that. They started giving me all these tips on what professional observing might be like, and those tips started evolving into stories. So people started telling me stories like, oh, did you ever hear that one about the person who got stung by a scorpion while they were working at a telescope? Or the guy who had a raccoon crawl into his lap midway through an observation? Or I know somebody who was sitting in one of the domes here on Kitt Peak when they were struck by lightning. They were fine, but it was the loudest sound they'd ever heard in their life. Or did you hear about this telescope in Texas that got shot? And I remember sitting at dinner and my fork was like stuck halfway to my mouth, just going, I can't believe these stories. This is fascinating. I want to sit here all night listening. And I simultaneously want to run off and start getting some stories of my own. And I realized later on what everybody was doing with that storytelling. It was something of a welcome to the mountain and something of an introduction to what I was about to experience, what the day-to-day life of an astronomer working at a telescope was like, and all of the many sort of quirks and foibles and like wacky tall tales that went around the field talking about what this job could actually involve. So years later, when I wrote The Last Stargazers, these were the stories that I had in mind. So this is my book that's available now, and you can read it to get this sort of behind the scenes look at what life is like as a professional astronomer. And I use my own background in the field, my own stories and adventures, and the adventures of more than 100 of my colleagues that I interviewed to give us this sort of window into how people study the universe and what our jobs are actually like. And these stories help sort of tell the human tales of astronomy, and they also help share the science and the scientific excitement that we have when we're dealing with some of the great astronomy discoveries of the past decade. So one of my favorite parts of this research was all the interviews I got to do with my colleagues, and I wanted to use some of these interview questions to take a few looks inside the book. I asked everybody these same 3 questions, and I got a great variety of answers, and I'll feature some of my favorites here. So the first question that I asked everyone was what they thought would surprise people the most about our jobs. What did my fellow astronomers think the biggest disconnect might be between what people think we do all day and what we actually do all day or all night? I think overwhelmingly the most common answer that I got was that we don't look through eyepieces. You saw those little cartoons of imagined astronomers and these guys looking through a little tiny telescope. And you can remember that huge mirror that I was standing underneath. So we don't look through these telescopes to do our jobs. Today, we capture digital images and use really cutting edge cameras to save the data that we get from the universe. But when people talk to me, they'll sometimes say, well, we used to look through eyepieces, right? Like back in the day, that must have been how we got data before there were digital cameras. Before there were digital cameras, we actually used some pretty fascinating technology to capture images. We used something known as a photographic plate. So you can see a slide of somebody holding one of these plates up. I actually just managed to retrieve this plate from my office. So you can see an example that I'm holding here of what a photographic plate is. So these are glass plates. You can see how immensely thin they are, that were specially chemically treated to darken when they were exposed to light. And for years, these were the tools that astronomers used to capture astronomical data. They would get a plate like this, and they would slice it down to size. They would chemically treat it to improve how quickly it darkened when light hit it. They would carry it up to the telescope, and they would install it at a camera. Sometimes that camera, by the way, in a typical telescope would be up here. And they would do all of this work in the dark, trying to avoid exposing the plate before they wanted to. They would then point this telescope to a star or a galaxy that they wanted to study, open the camera's shutter, and light from that galaxy would come pouring down into the plate, darken it, and you wind up with this little color negative image of whatever you were trying to study. Now, back then, we also didn't have a great deal of automation available, so an astronomer couldn't just load a plate in and then leave. They would typically have to stay in that telescope and ride along with the camera and the plate all night. They would sit in this little cold, dark cage up on the top of the telescope and ride atop the telescope for hours, kind of shivering next to the camera, moving plates in and out. You can see the photograph of somebody doing this as an example here, also that we could capture the data that we needed of the universe. And we're saving all this data on a glass plate. So people are sometimes disappointed to hear that we don't get a nice visual look during our jobs with our own eyes of whatever we're studying, but the immense physical challenge of trying to do something like capturing data on a photographic plate, or the places that we travel to today to capture digital data, are, in my mind, pretty incredible stories. And I got to hear a lot from my colleagues about how difficult it is to capture data, the challenges of this, and how, even though we may not look through an eyepiece, it's a pretty exciting way to do our research. Another answer I got from people in terms of what might surprise readers is the incredible adventures that we have as scientists. I think sometimes people picture astronomers as these sort of nocturnal creatures, kind of huddled in a dome all night, night after night, wearing lab coats, never really getting to go outside and do everything, and just sort of sitting inside a building, turning a telescope. And in reality, it's amazing the adventures that we have in pursuit of our research. Even getting out to some of these observatories in the middle of nowhere can be an immense endeavor. And we're usually at these very remote places in the middle of nature, at the mercy of nature sometimes, during our observations. So people had some amazing stories for me of some of the adventures that they really went through in pursuit of their data. One of my favorite stories, and a story that's quite famous here at my home state in Washington, happened at Monastash Ridge Observatory in central Washington state. This is a little observatory that's owned by the University of Washington, and we had a graduate student named Doug Geisler observing at this observatory back in 1980. He was actually getting the first night of data for his PhD thesis. You have to wonder if there's a little bit of a curse for PhD thesis observations. And he was working at this observatory alone. And like any good scientist, he was taking very good notes as to how his night had gone in the observatory's log. So you can see a little picture of his log here, and he's very carefully noting he observed for 10 hours. He observed from 10 to 4 a.m. He got 6 hours of observing done in total. He didn't lose any time. The sky conditions were excellent. He talks about, oh, it was a beautiful night. I got great data. He had a great night. And he went to bed early on the morning of May 18th, 1980, which might be a slightly familiar sounding date to a few people. So around 8 or 9 a.m. that morning, Doug woke up on the mountain at Monastash Ridge because he'd heard this sort of faint, weird booming sound, and he kind of half registered it and went, well, that was weird, and went back to sleep. And then he woke up at noon, which is astronomer wake up time. It was the perfect time for him to, step out, enjoy a beautiful sunny day on the mountain, get some breakfast at 1 or 2 p.m., and then get ready for another night of observing. So when Doug woke up at noon that morning, he opened the door of the observatory and he was just greeted with this landscape of solid black. He would grab a flashlight, and the flashlight beam made it about 10 feet in front of him before just getting swallowed by the air. There was this awful, sour brimstone smell everywhere around him. And he was standing alone on this mountain in the middle of nowhere, assuming he was living through the end of the world. This was back before we could just sort of look up a news notification on our phone. So he was sitting there thinking, I have just lived through a nuclear attack. What in the world has happened? He sprinted back indoors, found a radio, tuned the radio, and eventually figured out what had happened. Earlier that morning, Mount St. Helens had erupted about 90 miles to the southwest of Monastash Ridge Observatory. And an interesting thing about the way Mount St. Helens erupted is that it almost erupted sideways and blew off a side of the mountain. And this meant that the volcanic plume traveled from Mount St. Helens to the northeast, directly over Monastash Ridge and directly over Doug. So when he opened the door that morning, he opened it into the volcanic plume of an eruption that had happened many miles away. He was fortunately okay and safe, but it was one of the weirder wake-ups that an astronomer has ever had on a mountain. And of course, he took very careful notes of this in the night log. So that day, he reported that he'd lost 6 hours of observing time to a volcano. The sky condition was black and smelly. He took careful notes on everything that had happened, and this log entry has now gone down in history. He then very carefully covered the telescope because he knew that volcanic ash could potentially damage the telescope mirror, and drove home. So this was one of the more epic adventures that I'd ever heard from astronomers while they worked on the mountains, and it lent chapter 4 of my book its title, Hours Lost 6 Reason Volcano. So if you want to see the full set of chapter titles, you'll have to go and check out the entire book, but you might be able to get a little glimpse of chapter 5's title here, which I'll explain right now, because this was the second question that I asked people as I interviewed them about the book. I was curious about what they thought would surprise people, or what they thought their most memorable story was that they had heard from others. I was specifically looking for these sort of secondhand or third-hand or 10th-hand tales that they'd heard told and retold and couldn't vouch for the truth of, but that had entered the legend of the field and had become so memorable that everybody had a version of it pinging around in their heads. And by far, the most popular answer I got was, do you have the story about the telescope that got shot? And this is true. There is, in fact, a telescope that was shot. It was the 107-inch telescope. So that's a telescope with a 107-inch across mirror at McDonald Observatory in Texas. Now, at this observatory, there was an observatory employee who at some point became hell-bent. He was angry. There might have been some substances involved that shouldn't have been involved. He was having a mental breakdown on the mountain. He became hell-bent on destroying this telescope. So he went charging into this telescope in the middle of an observing night, drew a handgun, and fortunately didn't hurt anyone, but demanded that the telescope be lowered so that he could fire bullets into the mirror and destroy the mirror. And he proceeded to empty the handgun into the mirror. But a telescope mirror like the one you saw me standing under near the beginning of this talk is huge. These mirrors are a good 1.5 feet or more thick, and they're made of borosilicate glass. So imagine a Pyrex dish that's 1.5 feet thick. When he fired bullets into that mirror, the bullets sort of went in and stuck like darts being thrown at a dartboard. So he didn't get this epic shatter that he was expecting. The mirror basically did this. You sort of had these little pinpoints in the mirror where the bullets had embedded, but really not caused that much damage. He was fortunately subdued, he was taken away, and the crew took a look at the mirror and realized, this isn't that bad. This is pretty fixable. They were able to dig out the bullets, just paint over the bullet holes so that they didn't reflect, and keep using the telescope. The joke was that they just lost a little bit of size from this telescope, so it had turned from a 107-inch into a 106-inch. The only issue is that this was such a weird and incredible story to have happen at an observatory that the story left the mountain, made it around the astronomy community, and in that telling, the rumor got out that the telescope had been destroyed. So the observatory director had to put out a bulletin in a medium that was usually used for things like, hey, we found a new supernova, or we found a weird star that's getting brighter, somebody should check that out. He had to release a bulletin reassuring people that the harm suffered from this mirror by bullets that were shot at it and by some attempts to destroy it with a hammer by the same person were extraordinarily small. So it's one of the funnier observatory bulletins that I've ever heard described, and certainly made for an unusual but quickly very famous astronomy and observing story. So the last question that I liked asking everyone dealt with how astronomy had changed since they'd begun observing, because this is a field that really benefits from advances in modern technology, and we are very quickly seeing the results of any new or innovative approach to studying the universe in how we do our day-to-day jobs. So one answer was just straight up looking at the imaging technology that we have available to us. You can see this example of a really beautiful spiral galaxy studied with a photographic plate like this. So you can see what that sort of black on white image looks like. You can see the spiral arms of that galaxy. It's really a pretty great scientific image. But then we can compare that to what that same galaxy looks like when observed with Subaru, the telescope that I was at the very beginning of this talk. And you can see that immense, beautiful, multicolored image that we got from really top-notch digital cameras. And you can see just from looking the amount of science and the amount of information that we can get out of modern day telescopes and modern day imaging tools. alongside the technology changing, the way that we do our research is changing. So as part of my research for the Last Stargazers, I got to go visit Vera C. Rubin Observatory in Chile. This is an under construction telescope. It's named after the woman who discovered dark matter, and it has a deceptively simple but brilliant scientific goal. It is going to survey a huge swath of the southern sky over and over. It'll be taking pictures of the sky every few nights, again and again and again for 10 years. And it will wind up giving us a decade-long movie of the night sky. Now, that kind of data and that volume of data is tremendous because it means we can find anything that changes or moves in the whole sky. Any star that gets brighter or dimmer, a supernova, so a star suddenly getting incredibly bright and then suddenly fading away, or a star disappearing, something like an asteroid slowly moving across the sky. All of that can be spotted with data from the Rubin Observatory. This observatory creates a huge volume of data. It's on the order of a petabyte of data a month. And that data has to be computationally processed to find a lot of what I was just describing. So something that moves or brightens or dims. To do this, there's going to be a small crew on site at this observatory, but an astronomer who wants to use the data doesn't have to go there. We sit at home at our desks or at our computers, and we download the data as it becomes available, and we work on it from here. So we're no longer going to these telescopes. We're not sitting in a control room on the mountain or even sitting atop the telescope operating photographic plates. We don't stargaze in the traditional sense with the telescope like this. And I know that that can sometimes sound like a sad prospect, or this idea that we lose some of the romance of our field. But I really choose to look at it more as a shift in how we stargaze, with a lot of the science happening thanks to data gathered from telescopes like this that we can study and ask questions of and answer questions with, even if we're sitting at our laptop at home. So on that note, I know that we want to leave plenty of time for questions, so I will put the information for my book back up. I'm happy to answer any questions that you might have, and thanks very much for listening.
Thanks so much, Emily. That was fantastic.
Thank you.
Can you see? Oh, where's my video here? So I just had a couple questions. So I know that, astronomers work in various ways. We have theoretical astronomers working with math and equations, and computational astronomers who work with computer experiments. But you seem to be most fascinated, at least in the context of this book, with observational astronomy. And so I was wondering, it's natural to see the appeal. Do the other types of astronomy also have appeal for you? And how are those different? And also why observational astronomy is what really gets you?
So I got trained originally as an observational astronomer. My first astronomy class in college was with a professor named Jim Elliott, and he was just this absolute legend of observing, and really got me to fall in love with everything from just the nuts and bolts of getting a telescope up and running to sitting next to one in the cold, looking at data on a screen. He told me incredible stories about things like working on telescopes that operate out the open back door of a plane, which I had just never heard of before I took his class. And I like that sort of adventure, Indiana Jones-ish aspect of observing, and the fact that there is an almost expedition-like quality to it. Observing has taken me all over our own planet. I've gotten to fly into the stratosphere for it, gotten to so many continents and just some of the most beautiful places in the world. So those were the stories that I wanted to capture in the book. I actually do also do some computational and some theoretical astronomy, and I'm a big fan of we use as many tools as we can to answer the research questions that we have. And that could mean using everything from a radio telescope to a survey telescope to a telescope on a plane, or that could mean combining really intensive theoretical physics with the data that we take. But the ultimate goal for all of this is always answering these questions about the universe. And I just like that for observers, you're doing that by having these wacky adventures on Earth along the way.
Yep. Makes a lot of sense. So, so you mentioned, more and more astronomers are doing remote observing rather than actually going to the telescope and doing those observations themselves. How do you feel about that personally, but also from a scientific perspective? Do you think, are there advantages of that or disadvantages, and where do those lie?
This is a great question, and it's actually something that I spend a lot of time talking about in the book because it's such an interesting shift. I talked to a lot of people who had gone from sitting on top of a telescope with photographic plates to now when they can operate a telescope from software on their laptop. And there's some real advantages. It takes a long time to travel to observatories. It can be really grueling. Some observatories are at very high altitude. People will suffer health effects from traveling to them. So it's way more comfortable to just sit on, I've observed from like my couch, my living room table. That's a much more pleasant way to observe. On the downside, you do miss a little bit the experience of actually being there. I remember getting ready for an observing night that started at midnight and drinking a ton of coffee beforehand, going, all right, I'm going to be awake. I'm ready. I'm going to stay up until 5 a.m. And since I wasn't on the mountain, I didn't know until I booted up my laptop that they had been sucked in with clouds all night. It didn't show up on the radar. It was very low fog. And I remember the operator saying, yeah, no, you can't tell from the radar, but it's super foggy. We're definitely not going to open. Why don't you just go to bed? And I'm sitting there with like a billion volts of caffeine, like, okay, so there's practical issues, and you sometimes lose the ability to tweak your observing plans according to conditions. I think the access that remote astronomy offers is really great. It's been very important the past 6 months to have remote observing capabilities because of the pandemic and because of safety concerns. But at the same time, I really hope that going forward, we keep in the field a mix of remote observing and still getting to go, because there's real unique perks to both.
Right. So we have a question from YouTube chat. So My Moments of Zen is curious if you own or have ever owned your own telescope, and if once you get to use a telescope like Subaru, is having your own telescope a letdown?
So I'm actually really glad somebody asked this question. I don't right now own my own telescope. This has much more to do with the fact that I live in the middle of Seattle than with it being a letdown after Subaru, because they're truly two very different types of experiences. I've never gotten to look through Subaru. When I use a 8-meter or 10-meter telescope, I'm looking at the data as it comes in on my computer screen, and I'm looking at raw data and trying to sort of sort through and process it and get to the science questions that I want to answer. I still love looking through a little telescope, and I actually write in the book about what it was like to put an eyepiece on a very big telescope at one point and look through it with some of my fellow astronomers, which was great because it's all these like scientifically trained people, and you'd expect us to have all these like very deep observations looking through an eyepiece on a big telescope, and we're basically all going, ooh, like we sound like 8-year-olds looking at Saturn through a telescope for the first time. But it's just such a wonderful experience to see it yourself. And the big type of observing that we do is just so different. So I really appreciate both.
Great. So you talked about photographic plates and all of this technology that now we don't use, but was so important in the past. And so do you think it's important for astronomers or the general public to kind of think about how astronomy was done in other times and why? Or, you know, do you see like new technologies as also being like full of stories? And do you have any examples from more modern technology?
Oh yeah, I actually think it's really valuable to look at how the technology has evolved, because I think it can't possibly hurt to understand what problems we had and how we solved them, and what we can, like the knowledge, the sort of lesson from there to try and answer some of the problems that we still have today. I also think it's worth remembering the gains that we've made. Anybody that I interviewed that was senior enough to have observed with photographic plates, which is not necessarily that long ago, plates were still being used in the 80s into early 90s. Like plates are really not that old. They had a real appreciation for what we'd gained by going to digital imaging. And they also had a really clear understanding of what digital imaging entailed as opposed to photographic plates. So it meant they understood the tech and its abilities and its limitations really well. There's great stories of people working with photographic plates and like hearing them snap while they're sitting in a camera. Or I think somebody had a story once where they pulled a plate out of a camera and then dropped it, and they needed the data on it. So they went into the developing room and they're like developing the shards and trying to stick it back together. And that's more dramatic sounding than the, oh my God, I almost deleted my whole hard drive story. But there's still plenty of issues to be had with digital cameras. I've had colleagues who talked about accidentally frying an entire camera on the back of a telescope, or who have been operating a telescope remotely when their Wi-Fi goes out. And from the telescope's perspective, its astronomer has just disappeared, and they'll be like frantically biking to campus, trying to get to a working Wi-Fi network. So the stories change, but the stories don't go away. It's just a matter of, what quirks of technology we're currently grappling with as humans.
Right. Well, I also just want to say, I loved the story about those other astronomers kind of bringing you into the lore of astronomy, and like that being a huge part of the culture of astronomy. And so I'm so thrilled that your book is kind of sharing that with the larger world so that they can feel a part of our community as well. So thank you so, so much for speaking today.
Thank you.
And I'll be posting a link to a survey. This really helps us out. It helps us keep doing these sorts of events if you would fill this out. So it's a Google form that I am linking to in the YouTube chat. And thank you again so much, Emily Levesque, for all of your interesting stories. I can't wait to read the rest of your book.
Thank you so much.
Take care.